Definition of a function. A relation in which each input has exactly one output is called a function. Here are two examples of relations where the arrows go from the inputs to the outputs in both cases. First one is median income by state. Second one is engine size by number of cylinders. Let's take a look at the second one first. In particular, I'm going to look at the input 6. A 6-cylinder engine might be a 2.4 liter or might be a 3.0 liter. So we would have an example of an input that is mapped to two different outputs. The definition of a function requires that each input have exactly one output, and therefore this violates that definition, and this relation is not a function. Looking now at the first example, median income by state, we can see that each input has only one arrow coming out of it. The output 72 has 3 arrows coming into it, but that's okay. It's okay to have repeated outputs. It's just not okay to have ambiguous outputs like we have in the case of the input 6 being mapped 2 different directions. So this first example is a function. So this is the definition of a function. Where we spend the most time is getting comfortable with the function language, so let's go on to that right now. When we're referring to a function, we refer to it by its function name. So its function name would come first. In this model, we're just using the word function as the name, followed by the input in parentheses, and the result is equal to the output. In our sort of standard case, that would be a function named f, an input which is the x variable, and an output which is the y variable. And this is read f of x equals y. That x in parentheses, which is the input to the function f, we would read this as f of x using the word of. It looks like the same kind of notation that we sometimes use for multiplication, and this is one source of confusion, fairly common confusion, that we're going to have to get used to. But this is read as the function f applied to the input x gives us the output y. So for example, we can refer to our first function in the relation diagrams above, median income. We're going to name that function median income, and we're asked to find the median income of Indiana. I can see that Indiana is in the place of the input variable, so that tells me that Indiana is the input, and I am looking for the output associated with the input Indiana. Coming back up to this diagram, I would find Indiana, trace over to my output of 65, and use that 65 as my answer. The second question is saying find x such that the median income of x is equal to 72. This time we're saying I don't know the input. The input I'm calling x because I don't know what it is, but the output is 72. So I'm going to find the output of 72 and trace it backwards to see what inputs trace to it. Now in this case I do have more than one, as we already identified. The output 72 comes from the states Alaska, Colorado, and Illinois, so all 3 of these are going to be included in my answer, and I can use roster notation to express that. Alaska, Colorado, and Illinois would become the set of x values that are inputs to the function median income that give me the output 72. Now, understanding the function language, when the function name has a meaning like median income, and the input has a meaning like a state name, and the output has a meaning like a median income, is much more intuitive than using the function language when it's in this abstract context of f of x equals y. When x and y are both numbers, and f is just referring to some function that might be defined by a diagram like we saw, or it might be defined some other way, we have to know this language really well to understand what we're being asked to do. So we're starting it with a fairly intuitive example, but it does become much less intuitive when we get into the abstract examples.